Alright, now this is a different types of mathematical induction. This involves summation. Now it says use mathematical induction to prove that 1 square plus 3 square plus 5 square plus all the way up to 2n minus 1 all square is equal to n over 3 times 4n square minus 1 for all n is a natural number. So let's go ahead and do this together first, and then you're going to attempt the next one. So look at this right here, right? So as we can see, 1 square, 3 square, 5 square, we know the next number would be 7 square, 9 square, and so forth. All of that can be represented by 2n minus 1. Look at it. When n is equal to 1, you get 2 times 1 is 2, 2 minus 1 is 1, then you get the 1 square. When n is 2, 2 times 2 is 4, 4 minus 1 is 3, and that's how you get the 3 square. In other words, all of these things that we're adding, we can replace it with the summation symbol and write where we have the sum from r equal 1 to n of, we're going to change this now, change it from the letter n here to write 2r minus 1 all square. This is what we're going to be proving. We're proving that the sum from 1 to n of 2r minus 1 all square, we're proving that it's equal to n over 3 times 4n square minus 1. Alright? That is what we're proving. Now that that is what we're proving, alright? So first thing we're going to do is step 1. We know the magic step, let n equal 1. If n equal 1, then the left hand side is going to be the sum from r equal 1 to 1 of 2r minus 1 all square, right? And when you plug in n as 1, that just works out to be, plugging in r as 1, that's 2 times 1 minus 1 all square, which is just 1. Now the right hand side is going to be, plugging in n as 1, it's going to be 1 over 3 in bracket 4 times 1 square minus 1. This simplifies to be 4 minus 1 is 3. That is 1 over 3 times 3, which is just 1. So what do we realize? Both of them is equal. So therefore n equal 1 is true. Now that we've gathered that n equal 1 is true, now step 2. Step 2 is for n equal to k, right? For n equal to k. For n equal to k, what we're going to be having then is the sum from r equal 1 to k, because we replace n with k, of 2r minus 1 all square. And that is then going to be equal to, replace n with k, it is now k over 3 in bracket, where n is, we'll put k, it becomes 4k square minus 1. That is what we have, and we're going to assume that this step is true. Assume true. Assuming that this is true. Alright? Now guys, before you even do the next step, you need to write down what you're supposed to get. I love when you write down what you're supposed to get, alright? So look at it. Before we do the question, this is what we're supposed to get. Look at it. From the third step, we're going to put down what we're supposed to get. In step 3, we're supposed to get, we'll replace n with k plus 1. We're supposed to get k plus 1 over 3 times 4 in bracket, k plus 1 all square minus 1. This is what we're supposed to get. Wow! Supposed to. Once we get this, we know we're correct. So let's go ahead and try to get that. Hey! Now, this is how we do step 3 here now. So for step 3, for n equal to k plus 1, for n equal k plus 1, it is, please remember this, it is the sum from r equal 1 to k of the function which is 2r minus 1 all square, then plus the k plus 1 term. Please remember it for me. It is the sum from r equal 1 to k and then plus the k plus 1th term. I beg you please to remember. So in this case, it's going to become equal to the sum from 1 to k of 2r minus 1 all square. That is k over 3 in bracket 4k squared minus 1. That's the k. That is the sum from 1 to k, because that's what we said up here. Alright, here it is. The sum from 1 to k. We said it in the earlier step before that it was what? K over 3 times 4k squared minus 1. Alright, so just to show you where we got that from. Alright, so that's why we'll put that down right here. Alright, that's the sum from 1 to k. And then we need the k plus 1th term. Now to get the k plus 1th term, right, you're going to replace r with k plus 1. Replacing r with k plus 1, you're going to get 2 in bracket k plus 1 minus 1 all square. In other words, this simplified to be k over 3 in bracket 4k squared minus 1 plus, this is then k plus 1 times 2 is 2k plus 2, but then you subtract 1, it works out to be 2k plus 1 all squared. Alright? So in other words, look what I am going to do. Right? Remember, we need to simplify this in order to get it to be equal to this down here. So realize that first thing we need to do is factor out k plus 1, right? So in order to factor out k plus 1 first, look at this. We're going to put a 3 over 3 here. Because the first thing we want to do is factor out 1 out of 3. Factoring out 1 out of 3, we would have k times 4k squared minus 1. And then we have plus 3 times in bracket 2k plus 1 all square. So now we need to expand that. So now when we expand, we're going to get 4k cubed minus k plus 3 times in bracket first term square plus twice the product of the 2 plus second term square. We then need to go ahead and simplify some more to get 4k cubed minus k plus 3 times 4k squared is 12k squared, and 3 times 4k is 12k, and then 3 times 1 is 3. Close the bracket. Alright? So in other words, all of this is going to simplify to be, sorry about the dizzle dazzle a while ago. In other words, all of that is going to simplify to be 1 over 3 in bracket 4k cubed. Now you have 12k squared here, and we don't see any other k squared term, so we just put plus 12k squared. And then we have right here minus k plus 12k, that is 11k plus 3. Now guys, we need to factor out k plus 1. In order to factor out k plus 1, we need to divide this by k plus 1. You're probably saying, so much work? Yes. So guys, what we're going to do is go to a new blank page, write out 4k cubed plus 12k squared plus 11k plus 3. We're going to divide it by k plus 1. So you need to show this somewhere separate. Aww. Or you can show it underneath the working. K into 4k cubed is 4k squared. 4k squared times k, that's 4k cubed. 4k squared times 1, that's 4k squared. We subtract. 12 minus 4 is 8k squared. Bring down the 11k. Then we have k into 8k squared. That is 8k. 8k times k, that's 8k squared. 8k plus 1, that is 8k. And then we subtract. We subtract 11k minus 8k is 3k plus 3. And then we go k into 3k plus 3, that leaves plus 3. And 3 times k plus 1, that's 3k plus 3. And then we subtract. So this is what we get when we factorize it. Alright? In other words, what we're saying then is if we're going to factor out k plus 1 from 4k cubed plus 12k squared plus 11k plus 3, what we're saying is, look what we're saying now. What we're saying is this is going to become k plus 1 over 3 times. In this bracket becomes 4k squared plus, what did we have? 8k plus 3. Alright, all we did was factor out k plus 1. Alright, in other words, think of it with numbers, guys. Please, if this doesn't look as clear, think of it with numbers. If you saw numbers, let me do it on the white screen. If you saw regular numbers, I know it's a lot easier with regular numbers. Let's say you saw regular numbers like 5 in bracket 120, right? We can always take out a number like from 120 can go into 120. So we can always rewrite 5 times 120 as 20 coming out of 120 would become 5 times 20 in bracket. When you take out 120, when you take out 20 from 120, it would be 6. So we can rewrite a number like 5 times 120 as 100 times 6. That's what we're saying right there. Alright? So all we did was factorize. But in order to factorize this expression here, in order to factor out k plus 1, we had to do polynomial division. That's all we did. Now that we do our polynomial division, remember what we're working towards. We're working towards getting this, right? 4 times k plus 1 all square minus 1. So guess what we're going to need to do? We're going to need to what? Complete the square, right? We're going to need to complete the square, yes. So look what I'm going to do. The first thing I notice is that this is what? 4 times k plus 1 all square. So look how we're going to generate that now, you know. Look how we're going to generate that. Look at the beauty of mathematics. This is k plus 1 over 3 in bracket 4k squared plus 8k plus, you see this number 3? I'm going to rewrite 3 as 4 minus 1. Now you're probably wondering, why would you do that? Why? Because look at this. We can then break this up as factor out of 4 from these three numbers now. Factoring out of 4, we'd have 4 in bracket k squared plus 2k plus 1, and then we subtract 1. But then guess what? K squared plus 2k plus 1, that is what? K plus 1 all square. So now we get k plus 1 over 3 times. This part right here, we know that this is k plus 1 all square. So in other words, this becomes now 4 times k plus 1 all square minus 1. Now we get our answer. Now we can write, therefore, n equal k plus 1 is true. Once you do that, you can write thus, by principles of mathematical induction, you tell them that the statement that they gave us, therefore, I'm not going to write out the entire thing, I'm just going to write the statement is true. Wow! Due to lack of space, I just write it this way, thus the statement is true. Alright, so what we're telling them is indeed the statement that they gave us, this statement right here is indeed true. Nice. Alright, so now here's your question for you to do. I want you to pause the video and attempt this question. It says, given that Sn is equal to 5 plus 5 squared plus 5 cubed plus 5 to the 4 plus 5 to the n, use mathematical induction to show that for Sn is 5 to the n plus 1 minus 5 for all n is a natural number. Pause the video and attempt this question. Alright, as we attempt this question, right, the first thing we know that we're supposed to do is we need to test out the statement, right, for n equal 1. But before you can jump the gun and test out the statement for n equal 1, look at this. Remember, this is Sn, right? So Sn is equal to 5 plus 5 squared plus 5 cubed plus all the way up to plus 5 to the n. So what we're then saying is that Sn, in other words, can be rewritten as the summation from r equal 1 to n of, this is just 5 to the r. Look, when r is 1, you get 5 to the 1. When r is 2, 5 squared. When r is 3, 5 cubed, and so forth. That's Sn. So now we can then say that 4Sn is equal to 4 times the summation from r equal 1 to n of 5 to the r. And we're trying to prove that this is equal to 5 to the n plus 1 minus 5. Now we can do the proof by substituting n equal 1. That's step 1. So now the left hand side is going to be, this is our left hand side. Plugging in n as 1 is going to be 4 times 5 to the 1, which is 20. The right hand side is going to be plugging in n as 1 on the right hand side. Let's do that in black. That is 5 to the 1 plus 1, which is 2, minus 5. 5 squared is 25, minus 5, which is 20. Notice that these are the same, so we conclude what? Therefore, n equal 1 is true. Now that n equal 1 is true, let's move on to n equal k. So for n equal k, right, so for step 2, for n equal k, we're going to have that the sum from r equal 1 to n, and n is now what? K, and it's 4 of them, 4 times the sum from 1 to k of 5 to the r, it's equal to, replace n with k, it's 5 to the k plus 1 minus 5. Alright, that's what we have, and we're going to assume that this is true. Assume true. Wow! Now for step 3, which is n equal to k plus 1. So step 3 for n equal to k plus 1, what we're going to have now is the sum, right? For n equal to k plus 1, we're going to have the sum from r equal, remember the sum from 1 to k plus 1 is the sum from 1 to k. It's the sum from 1 to k. It's the sum from 1 to k plus the k plus 1th term. So it's a sum from 1 to k of 5 to the r, 4 of it, plus the k plus 1th term. Plus the k plus 1th term. Now what's the k plus 1th term? The k plus 1th term would be when we replace r with k plus 1. In other words, this is going to be, now remember this right here is 5 to the k plus 1 minus 5 plus the k plus 1th term, replace r with k plus 1. So this is then plus 4 times in bracket, replacing this r with k plus 1, it is 5 to the k plus 1. Alright, so this is going to simplify to be, this is now equal to 5 to the k plus 1 minus 5 plus 4 in bracket 5 to the k plus 1. So we just need to simplify this, right? This is just 5 to the k plus 1 minus 5 plus, this is now 4 times 5 to the k, right? And then we have plus, this is just 4 times 5 to the 1. That's all we have, don't it? That's all we have, right? Yeah. Now look at that right here. We have 5 to the k plus 1 plus 4 times 5 to the k plus 4 times 5. We know 4 times 5 is 20. And 20 minus 5, that's what? 15. Now, before we even simplify this any further, I'm just going to write down what are we supposed to get, right? What are we supposed to get? What we're trying to get is, I always like when you write it down beforehand, we're trying to get that 4sk plus 1 should be giving us 5 to the k plus 1 minus 5. This is what we're ultimately trying to get. That 5 to the k plus, it should be 5 to the k plus 1 minus 5. So let us see how we're going to get that. We're supposed to get, oh sorry, replace this with k plus 1. 5 to the k plus 1 plus 1. We're supposed to get 5 to the k plus 2 minus 5. So let's see, how are we going to get that? This look pretty weird. We're supposed to get 5 to the k plus 1. Now look at this, guys, right? Alright, so now look at this, right? I'm going to underline these terms carefully. Look at this, right? These all have 5 in it. These all have the base to be 5, right? So now that I saw what we're supposed to get, I'm just going to eradicate this line above. Alright, we actually didn't need this line. We don't need this line at all. Alright, so no worries, guys. Because we didn't write down what we're supposed to get, I put it in a step that you don't necessarily need to have. right? You don't necessarily need to have that step. All right, please don't go ahead and have that step. I want you to come back right here. This is what you're supposed to get, 5 to the k plus 2 minus 5. So look what we're going to do. What we're going to do is this right here, we're going to factor out 5 to the k plus 1. Factor out 5 to the k plus 1 from what? From these two terms. Factoring out 5 to the k plus 1, this would be left back with 1 plus, factoring out 5 to the k plus 1 from this, we're left back with plus 4. Then we'll put our minus 5. Now 1 plus 4 is 5. So now we're left back with 5 times 5 to the k plus 1 minus 5. But then 5 times 5 to the k plus 1, this is really 5 to the 1. When the bases are the same, we add the powers. So we get 5 to the k plus 2 minus 5. Now we're done. So now we can write, therefore, n equal k plus 1 is true. Wow! Now that we get that it is true, we can write, thus, by principles of mathematical induction, we can write that 4Sn is indeed equal to 5 to the n plus 1 minus 5 for all n, a element of natural numbers. That's how you do this proof right there. Alright, so this is the busy step. Alright, so realize that this question really wasn't too bad. This was nice.